All right, all yours, Vallabh.
Just a second. My screen is visible, right?
Yes.
Yes, we can see your screen. Yes.
I'll first show only the Arways visualization.
Ooh.
So this KCS model we put in the Arways,
Nice.
and then we'll just remove these links.
So the propeller is also there?
Yes.
Nice. How did you manage the propeller?
Huh?
How did you manage the propeller?
These hull is one link, and these rudder and propeller are other two links.
Oh, no, but where did you get the geometry for that?
It was on our KCS like ASV building. That's
Okay. You pulled it from there. Okay.
Yeah.
All right.
And then this joint state publisher, I put a Revolute joint over here and a continuous joint over here, so we can see this. It's moving about this rod.
Okay. Okay.
Maybe I will zoom.
So the rudder is at 0?
Yeah, rudder. This point is 0, 0, 0.
Stock should be at 0.
Okay, I will just change the coordinates then later.
Yeah. You can change that later on.
This for rudder and this for the propeller.
So, but why do we only see half of the geometry of the propeller?
Just a minute. Yeah. If we see through, in Arways these are like
Yes, sir. In both
ghost objects.
Gazebo and RS, we have some. At some angles, we see a proper, proper shape of the propeller, and at some other angle, we don't see it properly.
Oh, okay. So ideally, we should be seeing this in Gazebo, maybe?
Yes.
In Gazebo also, I saw the same issue.
Same issues are there in that too.
It's just a visualization, but other properties are correct.
Correct.
So for these collision geometries, I have added like disc, this circular disc for the propeller, and this box around this box.
Oh, okay. All
For
right.
the
That box rotates when you rotate the rudder?
Yes.
Oh, fantastic. Oh, wow. Okay, excellent. You have to teach me how you did this.
Yeah. Like we wrote this KCS base.urdf.zacro, this file.
Okay.
Uh,
Maybe before you go into the file, can you tell me like what the architecture usually looks like? Like what do we need for this to be visualized generally? What is the... So kind of a layman's overview, if you would.
Yeah, like for just visualization in Arways, we need a URDF file that will describe how the robot is supposed to look.
Okay.
And we need a launch file that will launch this Arways.
Oh, okay.
That's it. Like those will be the main two things.
What is there in the launch file and what is there in the...
Yeah, I will show this case's description.
Yeah, adding to what Vallabh said, so for making the URDF file, so we'll be requiring the model files of KCS, propeller, and rudder, and basically what that will do is it will help in our visualization. But you also need other properties such as these inertial values, mass, etc. Collision. So collision geometry is what Vallabh has shown as a disk or the box. So it's what we are trying to do is we are trying to approximate the overall, physics as a physics of the propeller as a, as a cuboid or something.
As a disk.
Yeah, as a disk. Yeah.
Okay.
So what we can also approximate this physics as the propeller itself. but during the simulation it may take some time. It will be slower. So that's why
Oh.
we try to approximate with simpler shapes.
So what happens in the simulation? So I basically will be applying forces on this collision boundary.
Yeah,
Okay, I'll be applying a force on the collision boundary. All right.
yeah.
Okay.
So what? So if we don't have a collision or the inertial values,
Hmm.
other whatever or rest all things is just for visualization. So if you see in the URDF file,
Hmm.
so whatever model files we have for the KCS hull or propeller, everything will be for use for visualization. But
Okay.
whatever we specify in the collision geometry and inertia, that needs to be a bit proper, so that I mean that will be essentially using will that the gazebo will be using it for calculating, I mean for simulating the physics. So this is
Oh,
bit
okay, okay.
so this is a bit important, collision geometry and inertial value.
Got it, got it. So what is the general architecture of a URDF file?
Yeah, so in general we have a like
Just,
a base link.
just a second. Yeah. All right. Okay, let's go ahead.
Yeah, so like we can check what all is there in a URDF file using this command check URDF and the name of that file.
Okay, all right.
So it shows us like this root link. The robot name is KCS and the root link is named as the base link. And then the root link is having a child link, which is the case. This namespace is
Okay,
KCS hull link, and then this link itself is having three child links, which
okay.
are KCS propeller, KCS rudder, and KCS rudder shaft.
Oh, okay.
So for each of these links, what we do is we define a visual geometry, like visual part of it, what color it should look, what geometry it should have, and where it should be placed, and all that.
Okay.
And we also describe its collision geometry, as Mother told.
I'm presuming RPY means roll pitch yaw.
Yeah,
Okay. All right.
and it's also its inertial geometry. For each of these links, we give these things.
Okay. So origin, geometry, material. Okay, in visual. Okay.
Yeah.
And collision, you have origin, geometry, no material here.
uh, I'm not sure like we can put or not, but this material name I have put yellow because like it is just a color,
Okay, okay. Got it.
and that's why that hull is yellow.
Okay, you have defined the material name yellow.
Yes.
Okay, all right. And then let's say in inertia, what do we have? Simply Ixx, Ixy, Ixz, Yy, Yz, Zz. Okay, six values.
And the mass.
And the mass. Okay. Mass value. So this is all in an XML format, right?
Yes.
Okay, all right, got it.
And after we have defined the links, we define the joints in between them.
So everything is defined as links, and then you have to define the joints between the links.
Yes.
It's more like for robots, right?
Yes, exactly like those serial manipulator.
Okay, all right.
And then fixed joint means it won't move. The parent and the child will be fixed together.
Oh, okay.
Then this revolute joint means about the axis that we specify, it can rotate.
Okay. And
And
what is
then
limit effort?
yeah, I haven't checked those.
Okay.
I think these will matter when the
So can it
Gazebo.
limit the, okay, I think the velocity can be limited. I think the,
Lower and upper are the angles in which these are there.
correct. So it should be somewhere specified to 35 degrees maybe,
Yes,
converted.
yeah, these are 35 minus 35 to 35.
That is minus 35 to 35.
Yes.
Okay. And what is this effort?
This I'm not completely sure actually.
Okay. Probably it is the amount of moment that is required to make the turn or something of that sort.
At least in RVs this doesn't maybe matter, but like in Gazebo it will matter. I think. Yeah.
Okay. All right. Okay. And then you have the parent link, or this joint is the hull link, and then child link is the rudder link. Okay. All right. Does this use DH parameters somewhere in order to do the computation? Do we know that? Like when they actually do the simulation and try to find the kinematics, do they use DH parameters?
Like we haven't like this is not having the physics at all. This is only the visualization part of it.
Oh, okay, okay. So where does physics will come in all in
Gazebo.
Gazebo? Okay, okay, okay. All right. And next comes the propeller joint. It is a continuous joint. So what is the difference between a revolute and a continuous joint?
So like actually, like I think it is supposed to be like once this value is reached, it will come back from here.
Come back from there.
That is what I was assuming. Like I searched in their Rambi's description. There they used for engine the continuous joint.
Oh, okay. Oh, wait a minute.
Is Manoranjan saying something?
Manoranjan is here. Yeah, yeah. No, I think what the thing means is it doesn't have a limit. It rotates continuously. That's what it probably means.
Yeah, there is quite a difference between the two joints. I don't remember it. Yeah, Ashwin is pointing.
Ashwin has shared some link on this. Okay, upper, lower, safety limit. No, but that doesn't give me the answer for continuous. Does it say continuous anywhere here? No, I'm not seeing that here. It is not on this link. Type. Okay, continuous. A continuous hinge joint that rotates about the axis and has no upper or lower limits. Whereas a revolute joint is a hinge that rotates along the axis and has a limited range specified by upper and lower limits. Okay, and you have
I haven't specified a lower upper.
Yeah, I think the other types are prismatic, fixed. Fixed is this really is not. This is not really a joint because it cannot move. All degrees of freedom are locked. This type of a joint does not require the axis calibration, dynamics, limits, or safety controller. Then you have something called a floating joint. This joint allows for the motion for all 6 degrees of freedom. And then you have the planar joint, which allows motion in the plane perpendicular to the axis. Okay, got it. Good. Okay, so this is how you define the URDF file, I guess. But then this is not called URDF, it's called XACRO. What is the difference between the two?
Sure. So basically, URDF is what is supposed to. We use URDF to define our file. Define the geometry and everything. So in a sense, for defining our model, we'll be using URDF. But what Zacro does is we'll be able to create a plugin of some sort, which we can use it. I mean, so so for instance, if you want to create say a wheel, so you can create a single file type Zacro, which is defining a wheel, and you can use this multiple times in another
Oh,
file, which creates instances of these Zacro outputs. So what will internally what will be happening is Zacro files will be converted to URDF files.
oh, it's like a class for the object
Yeah,
of sorts.
yeah.
Okay.
So URDF, but it will be following the same pattern. So Zacro files will be following the same pattern as the URDF files, but we will be able to create plugins if required. If we want that, we can create some plugins.
What is meant by a plugin,
Yeah.
Manoranjan?
So if you look at Vallabh, can you open any of the Zacro files in that ocean environment of? Yeah. Worlds is yeah.
Okay.
Yeah, yeah. But I'm not sure whether this will have that, but still.
You mean the macro, right? The macro and Zacro, both.
Yeah, yeah. So
That will be in that other one. Yeah, this.
yeah, so this is this macro, sir. So
Okay.
this is like a plugin which can be created, and from that we can call this plugin from other files, and we can
Oh,
use this particular as I mean it's just for modularity basically.
so here the name of the plugin. Can you go back to that file, Vallabh?
Yeah.
So my understanding, if I'm getting it right, is USV Dynamics underscore whatever name will be the
Yeah.
name of the plugin.
Correct. Yes.
Okay, and that plugin can be called as long as this macro is running in Gazebo, or I call
Yeah.
this macro in Gazebo.
Yes, that this another file in which we are supposed to include this, that will have a command like include this.
Include this
The
file.
name, yes, it will show the path of that, I think.
So then it's like a Python module getting imported or
Correct, sir.
something.
Yeah, it's exactly the same form. It has the same use. Yeah.
Okay, all right.
Yeah, like this include the KCS description URDF, this file.
Okay, all right. So now after I write that line, I can actually use that macro for doing something.
Yeah. Exactly.
Okay, all right. Okay, please continue. I am just asking questions wherever I'm complete layman in these terms, so you have to kind of really lay it down for me to understand.
We are so actually. We just what we did was like looked at the VAMVs, the VRX people how they did it, and we were experimenting what all is required to make the KCS one work.
Correct.
Yeah, well, did you attend that raw session? He
No.
had one whole session on this whole thing.
Sorry, come Ashwin, come again.
There were 3 raw sessions, right?
There were 3 ROS sessions.
Yeah, that we had for lab.
Oh, yeah, correct.
Yeah, one whole session was dedicated to this.
Okay.
Oh, I
About
thought,
the URDF or the entire Gazebo part also.
yeah, Gazebo part 2, I think.
Okay.
He explained all the joints, how to make joints,
Oh.
configure them.
Mhm.
Yeah, it would have been useful, I guess.
Okay, excellent. So, what do you call, everybody attended that?
No, like so I didn't attend that.
Okay. All right. Okay, so some slack to pick up for all of us. Okay.
Yeah, I can put the links, share the links of the meetings.
Yes, please do that. I think that will be useful for us to get up to speed on it. Okay, all right. So when you are running Can someone tell me, okay, I'm kind of talking about the base, so environment. When you run Gazebo, what exactly is happening? Which are the files which is fetching first, and what is happening next? Can anybody give me a process outlay of that?
Yeah, Manoranjan will be the person.
Yeah, sir. So the point is we will be defining all the things we want to start. I mean, all the things for the simulation in a launch file, right? So
Ah,
in that launch file, we'll basically start a empty world in Gazebo, and
okay.
that will start the Gazebo. And to we should make separate. Uh, I mean, to simulate to customize to our requirements, we
Hmm.
should create separate worlds that separate world files. So what you are seeing here is
Hmm.
a ocean world. So it will have uh, it will have codes which simulate the waves and the physics behind it. So we'll be creating a ocean world or whatever world that we want to simulate our simulate our vehicle in. So we need to create a world file and give it to Gazebo. So that will start the Gazebo with the world file in it. So all the in this particular case we were trying with in this particular case we are trying with a simple ocean world which will start which will start the Gazebo with a with a water area of some size. So it will
What are
start.
you some size? Okay.
Yeah. So and then we in that launch file we should also specify to spawn our vehicle in it. So what it will do is it will spawn the vehicle that we have just created in the world. If all our physics are correct, we should see the vehicles float.
Oh, okay. So when you say the waves, does it have a plugin for buoyancy and other things
Yes,
as well?
yes, it has.
This part is only the waves one. There is
So Vallabh, if you can show that yeah, wave Gazebo plugins. Yeah, this is the package which has all the code that is simulating the waves.
And that's written in C++. plus plus.
Yeah, it's written in C, I suppose. C or yeah, C++.
Okay, all right. So all of that environment, this has come from VRX.
Yeah.
Okay, so we are taking all those Gazebo plugins from VRX environment.
Yes, sir. So if we want to add code for creating a wave, can you go inside that Vallabh CSRC? So inside that we have this wavefield.cc, right? Can you open that? Yeah, so this has the code for simulating the waves. So we have all the parameters of waves, amplitude, direction, phase, everything. And currently it's simulating a PM spectrum wave.
Oh, where is it saying so?
Can you go down? Well, there is.
here it was, but okay.
Yeah, here they have defined the code for that. But yeah,
Wonder, any chance you can increase the font on
yeah.
this? I think it might be in preferences. Editor, a font and color. Font and color.
Oh, yeah.
Top bar. Yeah. Click that tick box. I think then you'll be able to change. Yeah, make it 20.
It is just okay.
No, you're making it smaller. Yeah, that's good. Let's go full screen. Yeah. Okay. All right. So where is it generating the PM spectrum? Let's
Yeah,
see.
can you go down? You should see it somewhere. Yeah. So this, not this. Can you go down? Yeah.
Pearson Moskowitz wave spectrum. Okay.
So if you want to include further, waves, we can specify our code here in this particular code.
So suppose when I spawn my wave environment, I want to use this PM spectrum. How do I go about it?
Yeah, so we have to specify this in our model. I mean, for we'll have a model.zacro, right? That's where we are specifying, no? Vallabh?
Yeah, model dot.
Yeah. In model.zacro, we'll specify the model name of our environment, wave environment model.
Okay.
So in this model.zacro, we'll have it. It will import the plugins from the other package. The wave Gazebo plugin package. So once we have that plugin, we can specify the parameters. Whatever parameters we want to change, we can do that.
So for example, if you wanted to do it here, what do we have to do?
Yeah, we just have to change the. So you have these model name, period, number, scale. So if we just change it, we can alter the wave environment.
But can we alter it to use the PM spectrum here all of a sudden?
This is currently using PM spectrum, sir, because the model they have mentioned PMS.
That's PMS. Oh, okay, okay. That PMS is what is specifying it.
Yeah.
I think I lost it. Where? Oh, okay. Okay. And then you specify the period. What is this number? Number is 3.
That certain parameters, I'm not really sure what that means, but they have kept it as parameters. These are some parameters which I'm not really sure of what they mean.
So this is not documentation. There's no documentation for this.
No.
Not very well.
Yeah, I didn't see any documentation properly. Maybe I didn't read the comments. I'm not sure.
Okay. All right. Vallabh, can you show me the directory where you have these files? I just want to understand the architecture of how the files are arranged. Even that is not quite something which I'm not quite sure. Can you maximize that? Let's see. So inside KCS underscore workspace. No, you are in KCS underscore workspace. That is the Catkin workspace.
This is Catkin workspace. In that SRC folder,
Course, okay.
KCS.
KCS.
Then KCS description had all the things that related to the URDF file that we previously saw.
Oh, just open it. So I see. Launch models. Inside models was it? No, you are inside URDF.
Inside models, we have the STL files.
Okay, all right.
Then in URDF, we have the previous one, the URDF description of the
This is
KCS.
where we define the links and the joints
Yes.
of the bodies.
Yes.
Okay, all right.
And then RVs is just, this is compulsory file, urdf.rv.
What is there in it?
It is just required to, like, I'm not sure what it is exactly.
Sir, it's just for RVS configuration, sir.
Yes.
So we may or may not require it, but if we can so if someone uses our package, they don't have to go to RVS, launch in RVS, and if you
Start
want
importing things.
start importing things, you can
This will automatically do that for them.
yeah.
So, but you didn't modify this.
No.
But then how does, if you didn't modify it, how does it know to go fetch the...
So that is done in launch.
Yeah, it will just have the configurations for RVS. So
okay.
Like the wind, all those.
Okay, got it. I think now I understand. Okay. And under launch is the KCS display.launch. Okay, this is the ROS launch file, right?
Yes.
Yeah,
This
the
will.
model is base. Okay. This is the file which you were editing. Then RVS config. This is where you're specifying the urdf.rvs file as the RVS config. GUI is true. Parameters, robot description. Main macro. Model. Okay. What is this command doing? Robot description. It's defining a parameter name. What is this command?
So that is the command to change Zacro files to URDF files.
Oh, so this is where that is happening.
Yeah.
So what you were telling me about.
Yes.
Okay, and then you have a node. Okay. Let's start a node with the name joint state publisher with a package joint state publisher GUI. I guess this is coming from Vishwas thing. No.
Like this was there was an article about I had made something like hand robotic hand, and that also included this. I'll just show that better. Yeah, like this uh, same methodology for that and this. This is just having many joints.
Okay.
So in that also the same this joint state publisher was used to just show like change these joints. So ultimately I would want to uh, like use some control to give like I will give some desired angles for these joints to reach. Then this hand will go to a specific grasp position.
I believe that's just a GUI, sir. So it's
Yeah,
just for
that
controlling the
just
joints.
yeah. So to see what angles to be given.
Oh, okay. That's just the GUI. Okay.
Just a GUI.
Okay. All right. Let's come back. Continue on the raw.
But from the GUI, we may also need to publish the joint states. So that's the other node name, package robot state publisher of type robot. Yeah. So that will publish the joint states.
Okay. That will publish the joint states. Okay. So this thing is starting off 4 nodes. Am I right in understanding that? It's starting RViz, it's starting robot state publisher, joint state publisher, and another joint state
GUIs.
publisher.
Yeah. Those first 2 are GUIs. The
First 2 are
last 2
GUIs.
the last one is RViz. Last before is the one that publishes the joint states, which is important.
Okay, and this is KCS display.launch. This is under that launch folder, right? Okay, can you go back to that folder? So all of that was under KCS description. Okay, let's come out of KCS description. Okay, then we have something called KCS Gazebo.
Yeah, this is we are still looking into. Yeah.
Okay.
This will have all the physics part for the vessel.
So the physics comes here, where in the Gazebo. Okay. Which files do we have to edit here?
All. Like currently this we just tried something like from whatever the VRX people had done, and we just took some. Okay. So we are still trying to understand what all is here, but we removed the extra stuff like
Thrusters, sensors,
and all of the other things were there.
So
Camera.
this is like a global file, sir. So you have to, assemble all your files. I mean, assemble all your plugins, assemble all your sensors, assemble all the dynamics plugins, everything in this file.
Okay, all right. So all of that comes into the KCS Gazebo folder.
Yes, sir. Yes, sir.
.urdf .zacro.
Yeah, so that will come under this.
Okay, and so this is so when you start the ROS launch file, it really doesn't start the Gazebo, right? You have to initialize the Gazebo separately.
Yes, sir. We have a launch. So the previous launch file you saw is just for RViz. So we have another launch file which does all that.
Yeah, in KCS Gazebo, I haven't currently put the launch file for this, but yeah, like in the Wave Gazebo, we world launch. Yeah. So in this, yeah. So here we call that robot. Yeah, KCS Gazebo.
Oh, so this is where it starts off.
Like this is will be the when we'll try to uh, like show in Gazebo, we will try start with this one.
The wave underscore KCS dot launch.
Yes.
Okay.
This will start Gazebo. I mean, this will start the Gazebo with our world argument, which in this case will be the ocean world.
Go up, Vallabh. Uh, where was the Gazebo launch command?
Can
Oh,
you?
below. It was there somewhere. It was written.
Yeah, this
Start Gazebo with world file.
Yes, sir.
Starts with an empty launch file, empty world.
But it will have an argument name where we can specify our world file.
So that world is defined here. Like currently for just for trial, put the same, but we will using the ocean KCS world.
Okay, then we'll be using the ocean KCS dot world.
That will come here.
Oh boy, this is quite confusing. Now, where is that file ocean KCS dot world?
That was in worlds. This.
It's under Wave Gazebo Worlds. Okay. It's quite. I'm still not getting the hang of it. Huh?
Yeah. So if you go to the main one, this is,
Yeah.
So if you see here, so KCS description and KCS Gazebo will have all steps related to the vehicle.
Okay.
USB Gazebo plugins and USB messages is a general plugin which VRX people have created. VRX people have used for publishing in certain topics. So it will have those, I believe, the sensor values. I mean, all things related to publishing the values in certain topics. These two packages will be used: USB Gazebo plugins and USB messages.
Okay.
It's just a general plugin, sir. We don't have to worry much about this.
We don't have to change much in that.
Yeah.
Correct. Okay.
Only if like if we say these people have already implemented the model that they have described in the theory of operation, that PDF that.
So they have defined a particular model for the Wambi vehicle. So we might have to change that here in our case.
So if we want to use say MMG model, we will have to change the USB Gazebo plugin thing.
Oh, so the physics will be governed inside this USB Gazebo plugins.
Can you open that USB Gazebo plugin SRC? Yeah, so these are some of the files. So the dynamics model of the USB and the thruster dynamics, everything is modeled here actually.
Okay. So this is what we need to change if we want this to mimic some other dynamics for the KCS. Then this is where you need to change. Suppose I want to add extra parameters which are not specified. This is where I would add those parameters.
Yes, we have to change this a lot, but currently
we just know what it is supposed to be.
I can see that now. Okay, I am now slowly starting to get the hang of this.
Yeah. So you will have other things also, Buoyancy Gazebo plugin. And
okay.
Yeah, so I think this is a general plugin.
This is completely general. This it just takes a link and it does the things that is like to get the buoyancy force for it.
Okay. All right. Okay.
Yeah.
This is USB Gazebo plugins. Yes.
Okay. So when we want to change stuff, that is the folder I need to look for, USB Gazebo plugins.
Yes.
Right? Okay. All right. Can you go back to the KCS? Yeah.
So now in Wave Gazebo and Wave Gazebo plugins, we have all the things that are related to the environment.
Okay. All right.
So in Wave Gazebo plugins, you will be creating plugins for simulating our wave environment. So wavefield.cc is the thing where so all these other files, Gazebo, geometry, physical constants, will just have the basic components of the wavefield.cc, which they will be importing, and they will be, it's like a global file which will be importing other header files, and here they will be specifying the wave model they will be using. So if you want to simulate, if you want to change the wave model, we have to specify it here. So currently we have the PEM spectrum waves, right? So we can add our code to simulate Schneider spectrum or anything. So
Correct. So that we can add here, and then we will be able to call upon it in the Wave Gazebo folder. When we launch it, we will be able to use that if you want to set the environment to be there.
yes, sir. So Wave Gazebo plugins is just for creating our models. We will not be doing anything else in that. In Wave Gazebo, it's again it will be like a global package which will be using this Wave Gazebo plugins to create the environment and call our vehicle from the other package, from the what is the KCS package, KCS Gazebo package, and also start the environment and create the
Using the Wave Gazebo plugins, it will generate the waves or whatever is the parameters. So suppose whatever spectrum I specify there, it can be called upon here.
Yes, sir. Yes, sir.
Okay, all right. Okay, slowly starting to get a hang of it. Slowly but steady. Okay. Okay, so therefore, when we want to implement this and kind of make the changes for our KCS vessel, so my understanding is, well, can you go to the KCS? Yeah. So I guess USV Gazebo plugins is where the physics needs to be updated.
Yes, sir.
Wave Gazebo plugins is wherever environment related stuff needs to be updated.
Wave Gazebo plugins in particular, because there only we are trying to simulate the environment, trying to create plugins that simulate the environment.
Correct. And then it will be under KCS description is only the geometry. KCS Gazebo is where the if I want to change
Assembly of that vehicle.
Assembly of that vehicle if I want to change. So suppose I want to add a LiDAR or things like that to it. This is where I'll have to make that change.
Yes, sir.
Okay, all right. Thank you. That's now starting to click somewhat together. Okay, so how far are we going right now with respect to changing the environment to suit our case? What all have we accomplished? What all do we need to accomplish?
So we were able to start just launch our vehicle in Gazebo, but that didn't quite come out as expected.
I'm not sure what happened.
Why? What happened?
Because I think the problem is we didn't specify the inertial values and other.
So it keeps rotating or doing something funny?
Yes.
Oh. So some of the physics needs to be corrected here.
Yes, yeah.
Okay. Ashwin, any thoughts on what to do here? Maybe because you went through the lectures?
I'm not sure if the wave plugins are working and the physics is wrong or something. I think it's something like that.
We didn't call the wave plugins in this one. Like we
are just putting the model in.
Yes.
Okay, this is because the physics is wrong.
Yeah. Like these currently the values for the inertia values are random only.
No, but I still want to understand why it would not settle down and
like it is. I'm not also sure. Like when Manoranjan.
Right now is buoyancy acting on it. You want to keep it at one place, right?
Oh, there is buoyancy acting on it.
When we tried with the ocean waves environment, the buoyancy was not working. It was dropping like this.
Okay.
It fell down. I mean, it was going down
internally.
Okay. No, but it seems to have stopped somewhere, right?
Yes.
Currently, it has stopped in the ground plane. This is the tiled.
Yeah. Why is it not like laying down?
Yeah, that's what I'm
wondering.
Whether the collision box is specified in such a manner that actually this is how the collision box is.
The collision for the hull is the itself, like the STL file of hull itself. For the rudder, it is that
Are you
box.
spawning from some height above?
See, it's lying on the rudder.
Yeah.
Yeah, it is lying on the rudder.
Correct. It is lying on the rudder.
So basically, only the collision box of the rudder is being seen.
Yeah,
And has
something
physics
is
on
wrong
it.
with the collision box of hull maybe.
But maybe the hull has very small properties compared to the rudder. Rudder's inertia properties are higher.
Rudders.
Yeah, can be. I'm not sure. This is for rudder,
Which is
no?
where is rudder?
Yes, this is
Rudder
rudder.
box. You see the rudder box, and where is the physics defined? Inertia. What are the mass values?
All of this is random for now.
Oh, mass is
Okay.
0.186. What is the mass of the hull? This is the mass of the rudder. Mass of the hull is more, isn't it? Then that's again the question: why it doesn't lie on the hull? Why does it lie on the rudder? Between all the different values, is the mass highest in this?
Yes.
Okay.
For Manoranjan's one, it ran properly. Like it was settling down.
But my inertial values were a bit different.
Yeah,
And
like
are you-
something.
Yeah, are
we
you
can.
spawning it from at some distance or like?
No, actually, like I put.
It's 000. I mean, that's the origin.
Oh, this is mine. Oh, wait.
Just try to spawn it from 0.
Like, it behaves even worse than this.
Ashwin, later on, please do share that links with me. I really want to see it.
Catechemical करे. We need to do catechemical also, no? After that.
करावं लागतं का मनोरंजन मागाशी मला नाही करावं लागत.
Oh,
Let's still try.
Now it is doing the same as what it did before.
Aditya is saying like we maybe need to do Catkin make first.
do
Like,
catechemical.
I think it has reflected. We don't have to make Catkin mechanism. Just check
Okay.
it. Yeah.
Yeah, use catkin build. You are using catkin make. Okay. If you use catkin build, I don't think you need to do redo like this make.
Oh,
You can just
Catkin-
build it once and it will reflect.
oh,
No, you can't do build now once you did catkin make. And you have to install it.
oh, the first time you did, you should do it
Yeah,
Catkin.
you need to delete all the other files, the
Oh,
catkin make files, then rebuild using catkin build.
okay.
okay. So for the first time, if we build using this catkin build, we need not do catechemical.
Yeah, you don't need to build it again.
Okay.
Okay.
Oh. Always one popped up.
Is it still doing the same thing, Vallabh?
No, the Arviz one came out right now. This one.
That's interesting. I am not quite sure what the physics is making it. Whoa.
It
See,
still came from height.
Yeah, only the rudder has physics on it,
Mm-hmm.
and it's doing some stuff.
So it seems like the physics is not acting on any of the others. That is why it is at a 35-degree angle, you see? Because that is the maximum at which the hull is stabilized.
Mm-hmm.
More than that.
That's why the hull was going through the ground.
Yeah. Hull can go through the ground because its collision box is not active.
Here also it is not showing like Manoranjan, like while we were looking. The base link is there, KCS propeller and rudder. Those three are only showing up here.
Okay, so I suggest why not we, who all are looking into this part? right now? Vallabh,
Me, Manoranjan, Aditya,
Aditya,
Sanjeev,
okay, why don't you pull Ashwin also? He seems
Ashwin
to
also.
have taken some lectures on this, which he may be able to share some information.
Yeah, I can look into it.
Okay, so pull him together as well, and we will try to see if we can get that collision part to be successful, so that at least the ship should float to begin with. With
Yeah, so
nothing
that's what
else.
we are trying to do. We are trying to make the ship float in the DEC environment.
Of course. Okay. So once that is done, once the ship is able to float and other things, don't we need to specify we'll need to change the dynamics model quite a bit. Suppose we want to get the propeller forces transferred, the rudder forces properly modeled using either the MMG model or some other way. We'll need to really work on that aspect, isn't it? Right. How hard is it to change the physics? Is it really complex to change the physics? Just leave it as is. Any
Currently,
thought?
I don't know how to do all of that, but like
Ashwin,
We
any
just
ideas?
have
Yeah, I think you need to solve the equations of motion.
Correct. I think it is already programmed. Some basic part is already programmed, but I think
Yeah.
what we want is we want to mimic it to be our MMG model or something like that.
Yeah, I'll need to look at it, see how they're updating.
Okay. All right. Why don't you guys all pull together? That will be useful, I think. Okay.
I will share this folder that we were working.
Yes, please do. Is that already shared with me? I too want
Yes.
to take it.
It's not on GitHub.
This is not
No,
on
but,
GitHub. Why don't we put it on GitHub? That's
Yeah,
the-
we can pull it easily then.
Yeah. Vallabh,
yes, sir.
let's do it on GitHub. Create a repository in that organization.
I tried one
We tried one doing on GitHub, but we are not very clear with how to do that git commands and all.
Yeah, it's right there after that on the top line. Yeah, right there.
no, this is
Okay.
error. I will search for it. Like I will later. Don't remember.
So you're not able to access or create a repository.
No, I created a repository. I put that KCS description one in the one of the branches.
Okay. Yeah, just add
This is an older one. Like, this needs to be updated.
yeah, just add everything up, git add and git commit, and then we should be able to pull from that. And then add all of us to that repository. Best would be probably to port it to the organization Marine Autonomy, and then I can just put everybody who is in that team, give access to that repository in one shot, rather than adding them individually. We'll set that up later. It is already part of that, isn't it?
It's not a part of this one.
Yeah, maybe we can do that to be a part of that. That might be easier. Okay, I'll help set it up today afternoon when we are meeting afterwards.
Yes.
Okay, then what we can do is we can share the GitHub repository and add everybody as a collaborator on it. Then they can simply pull it, make some changes, and then we are kind of keeping track of what is going wrong. Right, Ashwin? Anything else? Ashwin and Manoranjit, anything else to add to that?
No, sir. Yeah.
All right.
Yeah. Where are we going with this? Once we simulate it, what do we do with it?
Then I want to implement control on it. I want to implement Sanjeev's RL-based control on it.
Okay.
So that will what govern the rudder dynamics. So basically that will command the rudder angle. That should translate into the simulation, and then we should be able to see it do path following and other things.
Okay.
Sir, so currently the code in VRX doesn't model rudder, so that is something we have to think about.
So we have to add the rudder forces and other things.
Yeah. So that whole part is not there in the VRX code.
Okay.
The KCS description folder, I think, will have to be changed to like the rudder and propeller will have to be put in another URDF, like their own macros, I think. as KCS for WAMV, what with the VRX people, what they did is they put engine in another one, and the main model of the WAMV is in another one. You are the different files.
So the
So
propulsion is in different case and the geometry is in a different place. Okay.
the hull is in different, and only those engine is in different.
Propulsion is in a different place and the hull is in a different place. Okay. All right. We'll have to come up with the proper architecture for that to go through. What is the best practice? Who knows that? Manoranjan?
Yes, sir. Yeah. No, I think what PRX people are following is good, sir. They have properly maintained separate packages for everything, so we can probably follow theirs. I would
Okay.
suggest. So how they are, separating the packages out, that seems to be proper as far as I've seen.
Okay, so why don't we do it this way? Let Manoranjan and Ashwin be the guiding factors because they seem to be having some more knowledge than the others. Come up with the architecture of how we should put our rudder if we want to put it and propeller if we want to put it. And its dynamics needs to be included. How should we go about it? Can you both kind of think through it and then come back to us so that we all can start making progress in that direction?
Yes, sir. We both will sit down and take a look at this, make a proper architecture probably, and we'll share it with us.
Okay, because I think I tried something, but clearly that is not coming out as what we intended. So I think there's a requirement for some small change at least. Okay, all right. Now that part said, so later on we want to be able to import the sensors data from the craft, right? And then we want to be able to get that into a ROS node. All that is already existing. How does that tie up with Gazebo? So Vishwas part, how will that tie up with Gazebo?
Sir, so Vishwas part, now we are able to get the simulation, get the sensor values from his code, right? Or did I miss something? So
Correct. He will be able to give you, so from a real sensor, he will be able to get the values and give it to you.
So it will be published in topics, right?
It will be published in topics. And Vishwa, am I right in understanding that you're actually also fusing it together and then giving the state node estimator also is there a part of it, right?
Yeah. So it's been published as topics. So there will be two topics. One will be odometry, and then there will be acceleration separately.
But then, does it really make sense to put Gazebo and Vishwas sensor app together?
No, sir. Like for Gazebo, we have like sensors inbuilt, right? Like
correct.
The
so
simulation of sensors will be there, right?
Correct. Yeah. So the simulation of sensors is there. So we need your state estimation code.
Yeah, that I can give. Yes. Yeah, that I've already shared it in the repo itself. You can share it with everyone. So the ASV control repo has it.
Correct. No, but what I want is, Vishwa, is that I want you to sit together with all of them. See, the whole point here is of integration. The problem is not of sharing. It's a problem of integration. If we want to see this environment succeed, what has to happen is that sensors have to be simulated. So let us say we are looking at GPS and IMU is what we were looking at, correct?
Yes.
At least to begin with.
Yes.
So if that needs to be added to the Gazebo model of our craft. It should have a simulation. When we are running the simulation, it should also include a IMU and a GPS. What do you call GPS?
GPS, yes.
Those have to be read in by the node which you have created. Will have to be fused together in order to give us the complete state vector.
Yes.
Right?
Yes.
And another node has to be created where Sanjeev stuff is coming in, where it is subscribing to your nodes and it is formulating the new waypoints and it is giving the new this one and it is following that path. In fact, Sanjeev's part right now doesn't even have the path planning. The path planning is another thing which probably is missing in this entire architecture.
Yes. I understand, sir. Yes.
Right?
Sure. I don't think, yeah, that can be done. Integration of this into the Gazebo world wouldn't be much of an headache. That can be done easily. Yeah, I'll sit
Correct.
with them and I'll discuss.
Yeah, so please sit. I am kind of putting everybody together. Sanjeev, Aditya, Vallabh, Manoranjan, Ashwin, Vishwa. I'm kind of pulling you all together into this to let us see how to integrate it. I know it is kind of difficult. That is why we need so many minds to do it. But I sincerely feel that we should be able to achieve this. It's not unachievable, at least. It will be so cool to actually
Yes.
see the same model in simulation and the same model in reality. And I can exactly find out soon from Rakesh that where exactly our IMU and GPS will be located, where their base links will be located, where the propeller base link will be located, where the rudder's base link will be located. So then what happens? Our simulation model really mimics what is being done in the field. And when we see a difference between them, we can update our model slowly and steadily, where it starts to match better with our exact experimentation. Right? Then there is the fun part which begins. Then I can do new things. I can look at SLAM, I can look at other aspects, start putting newer sensors on it, simulate it in Gazebo, and then acquire those sensors, put it on the actual craft, and see whether the behavior is similar or not. Or at least that is the direction I want to proceed. Is that making sense, or should we make some tweaks to it? Ashwin, Vishwa?
Yes, sir. Seems
Makes sense, sir. Yeah, we can proceed in that direction.
Okay. Ashwin, anything else to add to it?
Yeah, no, sir. Yeah, it should be possible. It will take some work.
Possible, right? Yeah. So let's try that out. And also, I know that there are some second years here who are. Ayush, are you here?
Yes, sir, I'm here, sir.
All right. Please take this fellow also into the fold. He also has some experience with ROS and probably with a little bit of Gazebo, but not as much probably. So I kind of want to see that our knowledge base on this slightly improves. Okay. All right. Okay. All right. Now, with respect to Sanjeev's stuff, Vishwa, were you able to get that to into a ROS node? You were trying to get Sanjeev's code running inside a ROS node, right?
Yes, sir. Yes, sir. I am getting some weird results in that. The thing is, I'm able to load the model, but then it's showing some error, and I'm trying to look into what error is that, but still not resolved. Still looking into it.
Okay.
Takes some time.
Sanjeev, why, can you also help out with him? Is that on the ROS side or is it on the?
Yes, sir. It
On
has to
the
do with TensorFlow a little bit, sir. So we were
yes,
looking at it yesterday.
It's on the TensorFlow side, is it?
Yes, sir.
yes.
Okay. All right. What is the error, if I might ask?
It's some error with the EF environment. EF underscore environment package. It's not able to create the implement the Pi environment over there. That's the error it's showing. I checked on the internet. I just found one site which had a possible solution, which said that maybe libraries are outdated.
Mm-hmm.
Yeah, that could be one possible reason. So I tried updating everything, but it's still showing the same. So I need to brainstorm a little more on the errors.
Okay, so why don't you put brains together with Sanjeev? I would like you to
Yes,
both of you to work together,
yes,
find
sir.
a
Yes, sir.
solution for this. See,
Yes.
all I am seeing is I am seeing the big picture jigsaw puzzle. I can kind of imagine it that it will all fit together nicely, but of course, easier said than done. But I want to kind of see that happen in some sense. Okay, I really feel that it will be so cool to have it, right? And then we can even put in our wave basin environment. Once we are able to get even a base environment running, I think then we can add more stuff to it, make it more rich, more exciting. Okay. Anything else that I have missed in the entire thing that we were talking about? Did I miss anything?
Sir, also like regarding the paper submission, we should also start writing the draft, I believe. I mean, it's 10th today, so
Yes,
we should
we are
start.
already on the 10th and we
Yeah.
have another 14 days to go. So we should
14
definitely
days.
start writing the paper.
Yes.
Okay, and definitely we need to start. But that's okay. We will see, Vishwa. Okay, I know that it's especially that paper is having a tall order because we promised a lot in that,
Yes, sir.
right? So we
Yeah.
will take stock of it. But this simulation model is required in order to, if at all, to try anything out, or either an experiment is required. But experiment may not happen within 31st December because we are having some issues with the wave maker and other stuff, which needs to be resolved before we get access to the complete thing. So our experiment may be a little later, so we may not be able to do it before. Oh, I think the part I forgot about is Avanish part of the ROS code. We need to get that. Anybody has that or nobody has that right now? Vishwa?
No, sir, I don't have access to it.
So we need to get access to that so that then we know exactly how the command can actually be transferred to the Pi, and the Pi should be able to give the commands to the Arduino. All that architecture is also required for us. Right?
Yes, yes.
Not in the simulation format per se, but in the real implementation, when we actually want to implement on the vehicle, that will be important because Sanjeev's node will give out a control signal which has to translate into a action on the stepper motor, or it has to translate into an action on the BLDC motor. So that part of the code I'll get from Avanish, and then we'll try to put everything together in that GitHub repository. So Vallabh, let's create one. We'll do that today itself, and then add all of these people as collaborators so that we can get access to it and we can start seeing it all in action together.
Yes, sir.
Okay.
Sir, I think I have Avani's code.
Yes, Manoranjan, go ahead.
Yeah, I think I have Avani's code, sir. He sent me once. Both the ROS code and the Arduino code.
But there has been some changes, Manoranjan. I
Okay.
get an updated one because what happened is initially our RF control was giving us a lot of trouble.
Correct.
Then they tried to fix something with it, which I have yet to go and understand with them, sit together with them and to understand what is going wrong with it.
Okay.
And then we'll port that code as well into our repository.
Yes, sir.
Okay, what I suggest is what we will do is we'll keep two separate branches, one for the simulation branch and one for the experiment branch, and we'll keep the two codes separate. The experiment branch need not have the gazebo, the simulation branch need not have the sensors and other things because that will be simulated by gazebo. So some sort of a disconnect between the two will be required. Okay, all right, sounds good. Anything else, particularly on this topic? Nothing else, right? So let's put our brains together, guys. I think we can achieve this. It's very much doable. It's just a question of, I think, the starting inertia is very high because a lot of learning curve is required. But the moment we are past the tipping point, I think it will not be that difficult. So let's try it out. And Ashwin, please do share that resource. I want to kind of get up to speed and be able to appreciate this better.
Okay, yeah.
Okay, I'm going to stop recording now.